Hey guys, welcome back to the Algebra series. Today I'm going to cover PEMDAS and properties of real numbers. This is really the boring stuff that you need to know before we really get to the meat of the algebra, so don't worry if it sounds a little dry. It'll make more sense and not be so dry when we actually get to solving problems later in the video. So, PEMDAS. What is it? PEMDAS is basically an order you use whenever you start to solve a problem. So it stands for parentheses, exponents, multiplication, division, addition, and subtraction. A good acronym to remember this is Please Excuse My Dear Aunt Sally. This is the one that's often taught a lot. My teacher actually taught me something that was a dig against our other school near us, and it's People Eat Mud down at Strickland. So really just use whatever kind of acronym helps you remember it. One side note, parentheses also refers to brackets and absolute value bars. Also that kind of bracket. Let's go ahead and erase that. So let's look at an example. 2 minus 1 plus 2 times 1 plus 1 to the first power divided by 2. So right off the bat, let me write out our handy dandy acronym. Right off the bat, we can see that we have these parentheses. So what we want to do is rewrite this, but add the 1 and the 1. Okay. For the parentheses are taken care of. Now we want to apply the 1. So 2 to the 1 is 2. Okay. Now we get to the multiplication and the division. And a good general rule of thumb here is you want to solve the multiplication and division left to right. And it doesn't matter what order you do these two. You just do them left to right. So let's do that. And go ahead and divide that. Let's drag us down real quick. Okay. And now we can just do the addition and subtraction. So 2 minus 1, 1 plus 2. That gives us 3 for our final answer. Okay, let's erase everything and get it out of the way. Alright, next I want to explain the properties of real numbers. And they're good to know. You need to know them. You don't always need to know the name of each one. You just need to know how to use them. So first off, let's look at the commutative properties. The commutative property of addition basically means whatever order you add things, whatever order you add two numbers, it does not matter. This is the same as this. And this also leads us to the commutative property of multiplication. Multiplication works the exact same way. Okay, next is the associative properties. The associative property of addition it's kind of like the commutative property. Basically, it's saying, hey, these two numbers being added here, it doesn't matter if you put the parentheses around these ones. These are the exact same expression, basically. And there's also an associative property of multiplication. So, something like this also equal that. Those give you the exact same result. This works for division as well, and then the addition works for subtraction as well. Okay, next is the distributive property. So, easiest way I can explain this is it's when you're adding two things in parentheses and you are multiplying by something. And it doesn't have to be a whole number. You can also be multiplying by a fraction. But basically, when you're performing some sort of addition or subtraction in here, you want to distribute this, the coefficient, to the inside numbers. So this will give you 6 plus 10, or 16. So that's the distributive property. Okay, next is the identity properties. These are pretty easy. You add 0 to a number, you get that number back. You multiply something by 1, and that will get you that number back. Now let me explain inverse properties. The inverse property of addition basically says that adding the negative version of a number to itself equals 0. Multiplication. For multiplication, the inverse property says multiplying a number by 1 over itself, or the reciprocal, equals 1. Okay, now that we have that out of the way, let's get into some examples. So, say someone wants you to evaluate an expression. So we have 7x plus 5 minus 3x plus 5, and we need to evaluate it for x equals 3. Okay, so first we simplify this a bit. Basically, whenever you start working on an expression, what you want to do is you want to get the constants and the variables together. But first let's do the distributive property. Now, you might be thinking there's no number in front of here, and you would be wrong because there's actually a 1. So if you want to, you can write that out. That might be helpful. But we will distribute that and rewrite this. And don't forget to distribute the negative to the 5. I know it can be pretty easy to forget that sometimes. But now we can go ahead and combine these like terms, the constants and the variables. So 7x minus 3x give us 4x. This will be, these will cancel out. We'll get 4x, and we need to evaluate that for x equals 3. So now we're at the point we can just plug this in. And that gives us 12. Now, if you wanted to, you could have plugged this in to begin with and gotten the same answer, but it's always nice and it's good practice to simplify for expressions first. Okay, let's try one a bit more high level. We'll have square root of x squared y cubed times 1 over y. We'll evaluate this for x equals 3, y equals 2. Okay, so how do we simplify this? Well, first thing you want to do is simplify what's in the square root. Don't worry about the square root. Just make whatever's in it as simple as possible. So the way we can do this is we have 1 over y and y to the third. We can cross that out, and this becomes y squared. Okay, so now we have x squared, y squared, square root of that. And this is helpful a lot of the time for if you don't want to go through the trouble of cubing something, or I don't know, say there's some sort of bigger exponent down here and bigger exponent over here. It just makes things a lot easier. Okay, so let's go ahead and plug everything in. Square root of 3 squared times 2 squared equals square root of 9 times 4 equals square root of 36, which gives us 6. Okay, so let's go over the difference between an equation and a formula. Basically, an equation will say these two things are equal. X equals 6. But with formula, it often involves multiple variables in order to find some value. So say you're finding the area of something, like the area of a triangle. The area equals 1/2 base times height. And that is a formula. So let's go through an example. Let's put this into use. Find the area of a triangle, base of 5 and a height of 4. So pull out the formula again. And then we just plug in our values. and then we just multiply it out. So eventually we get an area of 10. And if you want to see what this looks like, here is a visual, not to scale. Our base would have a length of 5, and our height would have a value of 4. Okay, for the last one, we're going to simplify the following expression. Solve for x using a calculator, and then round to the nearest 100th. Okay, so here we go. Negative 7.2, 0.63 plus 2.3 plus negative 10.2 plus 12.5 to the fourth power times x equals 4.7. Now, for these, you can combine terms and everything, but really, you just need to get this big piece right here and this piece and combine them together. Okay, so how are we going to do this? We can add this whole expression right here to both sides of the equation. Okay, so what do we have now? Fourth power times x equals 4.7 plus 7.2 times 0.63 plus 2.3. Okay, now what I would do is I would divide by this whole thing. If you think about it, this whole expression in front of the x is basically just a coefficient. It's something we're multiplying by the x. So what we can do is we can just divide both sides by this coefficient. Okay. Now this might look a little scary, might look a little complicated, but these both cancel out, and what we're left with is our x equals this right side. So what we can do is enter that into a calculator. So we have 4.7 plus 7.2 open parenthesis times 0.63 plus 2.3 Let's close off both our parentheses and divide all of that by parentheses negative 10.2 plus 12.5, close the parentheses, raise it to the fourth power, and bada bing bada boom, that'll give us our x. It's asking to round to the nearest 100th place. So x equals 0.92. And there you have it. That's basically all you need to know for PEMDAS, the order of operations, and properties of real numbers. See you in the next one.